Hello, my dear students. In this session, we'll try to understand the meaning of universal law of gravitation and we will solve one or two simple problems based on that. So, according to universal law of gravitation, if there are two bodies, okay, if there are two bodies, the gravitational force between them, okay, will be directly proportional to product of their masses, and that force is inversely proportional to the square of the distance between them. So, gravitational force between two bodies depends on the product of their masses and it also depends on the distance inversely. Okay, this universal law of gravitation was given by Newton in the year he published this in the year 1687. Okay, 1687 in his famous book Principia. So name of the book, actually it was written in Latin language. Later it was translated into English because at that moment Latin language was a prominent language in Europe, like how it was Sanskrit before in India. Okay, the name of the book is Philosophiae Naturalis and Principia Mathematica, meaning natural philosophy and principles of mathematics. Okay, we'll try to understand this universal law. Say there is a body of mass m1, there is another body of mass m2. Say the distance between two bodies, let it be r. Okay, according to universal law of gravitation, the gravitational force between the two is directly proportional to product of their masses, and that gravitational force is also inversely proportional to square of the distance between them. Okay, so meaning we can write this as F is directly proportional to m1 m2 divided by r square. Okay, or there is a constant here, there is a proportionality constant g. Okay, we call this g as universal gravitational constant. F is equal to g into m1 m2 divided by r square. G is known as universal gravitational constant. Universal gravitational constant. The value of this constant was calculated later by someone called Henry Cavendish. Okay, so value of this universal gravitational constant is 6.67 into 10 to the power minus 11. So how to calculate the units? Okay, G is equal to F into R square. I can write an equation for G here. G is equal to F into R square divided by m1 m2 divided by m1 m2. So F means Newton, R means distance, correct na? So distance square, Newton meter square. This is kg into kg square. Kg square will go up. So what happens? Newton meter square kg to the power minus 2. So this is the value of G. Why we call it as universal gravitational constant? Because it is independent of the medium between the two bodies. Okay, this value of G is constant everywhere in the universe. Like in the first chapter, in straight line, we studied something called G, correct na? G. What is that? This is acceleration due to gravity. What is this small letter G? Acceleration. It is actually acceleration. Okay, that is acceleration due to gravity. That changes when you go up, when you go down. That acceleration due to gravity changes. Okay. What is this capital letter G? Capital letter G means it is universal gravitational constant, means whatever may be the medium in between the two masses, wherever you do the experiment in the entire universe, the value of G is always constant. That is why we call it as universal gravitational constant. Okay. Now we'll solve a simple problem. Force between two equal masses separated by a distance of 1 meter is 6.67 into 10 to the power minus 11 Newton. Calculate the value of each mass. Okay, the formula that we are using, F is equal to G into m1 m2 divided by r square. Force between two equal masses, I call both the masses as m. Okay, separated by a distance of 1 meter is 6.67 into 10 to the power minus 11 Newton. Okay, the force is this. Force is 6.67 into 10 to the power minus 11 equal to G. What is the value of G? 6.67 into 10 to the power minus 11 into m1 m2, two equal masses m and m. So what happens? M square divided by, separated by a distance of 1 meter. So r square means 1 square is 1. So what happens? This 6.67 gets cancelled. So what do we get? We get m square is equal to 1, or m is also equal to 1. Okay. So therefore both the masses have a value equal to 1 kg. Okay. This is just a simple problem, just for understanding the formula. Okay. These type of simple problems will not come in examination, but still I'm solving it to make sure that we know how to use it. Okay. What is the net gravitational force on mass at B? Okay, here there is a equilateral triangle, three equal masses M, M, M. Okay, they are kept on the vertices of an equilateral triangle at points A, B, and C respectively. What is the net gravitational force on mass at B? Okay. Okay. See, what is the net force here? See, mass A, okay, is attracting this mass B in this direction, correct? With some force. Correct? Because this mass M, okay, is attracting this mass in this direction. This mass M here is attracting this mass in this direction. Okay. Magnitude of both the forces are same. This also F, this also F. Why? It is an equilateral triangle. This distance is equal to this distance. Distance is same. Masses involving are same, because here M into M divided by R square. Correct? Now here also M into M divided by R square, because distance is same. So magnitude of both the forces is same here. Okay. So what is the resultant force? Angle between the two forces is 60 degree. Correct? Now what is resultant force? We know this formula. F is equal to square root of a square plus b square plus 2ab cos theta. Square root of a square plus b square plus 2ab cos theta. Yeah. So what is the net force? Net force is therefore is equal to square root of this force is F, this force is F. What happens? F square plus F square plus 2 F into F square, 2F square into cos theta, cos 60. What is cos 60 degree? Sin 30 is half. So therefore cos 60 is also half. So what happens? Net force will be equal to F square plus F square, 2F square. Cos 60 is half, correct? Half. So that 2 and 2 gets cancelled. Here also we get F square plus F square plus F square, 3F square, square root of 3F square. Okay, because why? Since cos 60 is equal to half. What is square root of 3F square? Square root of 3F square is equal to root 3F. This is equal to root 3F. Okay, what is the resultant net force? Root 3F. But what is F? That we have to find out. What is F? What is F? F is equal to G into M1 M2 by R square. Correct? If the distance between the two masses, if I take it as R, say this distance is R, this distance is R, this is also R. Correct? So then what happens? F equal to G into M square divided by R square. M square divided by R square. So therefore net force is equal to root 3 into G into M square divided by R square. So this is the net force. Okay. So similarly, net force on this mass is also same. Net force on this mass is also same. So hope you can understand how to calculate net force, because force is a vector quantity. So here we have to use vectors, and we have to use the formula F is equal to a square plus b square plus 2ab cos theta.